Hello, AP Physics 1. It's Mr. Ng with Giancoli, page 39, number 24. It's another kinematics problem. Here is our problem. A world-class sprinter can burst out of the blocks to get to its top speed of 11.5 meters per second in the first 15 meters of the race. What is the average acceleration of the sprinter, and how long did it take for her to reach this speed? Okay. So number one, let's do VVATX. V, V, A, T, X. So V initial, V final. Our V initial is 0, right? Because behind the starting line they're stopped. And then the top speed becomes 11.5 meters per second. And it's done in 15 meters, so that's our X, 15 meters. What is the average acceleration? That's what they want to know first. And at the time, we don't really know. It does want to know it later, but let's ignore it for now. So that's part one. I have my variables filled up. So I'm looking for VVAX, VVAX, not this one because it has a time in it. Not this one because it has a time in X. Oh, look at this. V's and X's with no time. So let's try that one. Part two. I found the right equation. This is our V final squared is equal to my V initial squared plus 2a, our acceleration, and then x minus xo, you should recognize that as just delta x, like the change in distance. In this case, our change in distance is just going to be 15 meters, so let's just write delta x. Okay, so we want to solve for a, so let's rearrange the equation a little bit. So vf squared minus v initial squared is equal to 2a x. I'm going to divide both of these sides by 2x. If you're worried about the delta here, I'll write it in for you. Here's the delta, the change in x. Hope you're happy. So now this 2 and x cancels out, so that means a, the acceleration is equal to the v final squared minus v initial squared over 2 delta x. The initial was 0 anyways, so acceleration is equal to v final squared over 2 delta x. That's our final simplified equation. Let's plug in, or that's our third step, or final step, I don't know. V final is 11.5 meters per second. We're going to square that. Divided by 2. Delta x is 15 times 15 meters. This becomes meters squared and seconds squared. This is a square. So if I do all that math, my acceleration becomes 4.41 meters per second squared. Look what happens, right? Once the square comes in, this becomes meters squared divided by meters. So this is just meters is left. There's no seconds here, so I'm stuck in meters per second squared, which is great because I wanted acceleration anyways. So we just found out what A was. Sorry for the drastic change in the slide, but in the last slide, we just figured out that A is 4.41 meters per second squared. That's great. We have our initial velocity still and our final velocity still and our delta x. The last part of this question wants to know how long does it take for this sprinter to reach that speed. So we need to find time. The best equation to use here is going to be this one, right? I mean, some of you might fiddle around with this thing, but I think this top one is way simpler. If you do use this bottom equation, you'll probably still get the right answer, but why put in all those extra variables? You don't need to do it. Here, let's try V final is equal to V initial plus acceleration times time, right? So let's just solve for time. Let's rearrange it. So that means V final minus V initial divided by A is equal to the time. So let's plug in. Our time is going to be 11.5 meters per second minus 0 divided by 4.41 meters per second. So our time, meters per second squared, right? So this unit cancels out. The only thing left is a second. So our time is going to be 2.61 seconds. Great. Again, first, fill in those variables. Next, choose the appropriate equation. FYI, more than one equation can do ya. Try to do the simplest one, and then plug in and solve. Thank you very much for watching.